Okay, today I'll give you more examples about how to write the whole proof of hypothesis test. So first step, you need to state the null hypothesis and alternative hypothesis. So for the null hypothesis is always the p0 equals to a some number, and then the alternative hypothesis is either greater than a number or less than that number. It has to be the same number as the null hypothesis or not equals to. Remember, our null hypothesis is our assumption for the population, and then the alternative hypothesis is what we want to prove. Okay, and then we check the central limit theorem for three-step independence, randomization, and the success failure rate condition. Okay, remember when you test it, again, this hypothesis is built around the null hypothesis. So that's why when we times the success rate, it has to be the null hypothesis success rate. It has to be greater than 10, and this is less than 10. Okay, so we set up the central distribution of proportion, which is mu equals to p sub 0, and sigma equals to p sub 0 times q sub 0 divided by n and take square root of it. And then z score equals to p hat minus mu over the sigma. So what's the difference between these two? You should end up with the same results. For example, let's say this is a right-tail test. Our z-score test is a standard deviation of a standardized normal distribution with a mean 0, sigma equals to 1. So this is 1, 2, 1, 2, 3. Negative 1, negative 2, and then negative 3. So our z-score, if it appears to be here, that would be our z-score. And then we will have our p-value. When we put in a GeoGebra, you need to put the mu equals to 0 and sigma equals to 1. But what about sampling distribution? The center is going to be what? The p hat with the mu of p naught, and the sigma is square root of p naught q naught divided by n. So we should have the center of p naught, and then add 1 standard deviation and add 2 sigma. Oh, subtract. So this is p naught, the center would be p naught, and then this subtract 1 sigma, and then subtract 2 sigma. So our p hat, instead of z-score, this has p hat, should be in here. So we will have a p-value. No matter which way you use, they should have the same p-value and z-score. And then we found the p-value from GeoGebra and evaluate it. So for the right-tail test, we have our p-value on the right side, which is greater than, larger, or more than these keywords. This is going to be our p hat. This is p naught. And then for the left tail test, it's the same. Our p hat is here, p naught is in the middle, in the center. So this is going to be our p-value. So the only thing we need to be careful about is the z-score. I mean, not the z-score, the two-tail test. So two-tail test is, this is p hat. So whenever you find the p hat, which is maybe here, that would be our p-value. We need to times 2. This is also our p-value. So this is the two-tail test. Okay, so conclusion. Conclusion, you need to say that, hey, are you going to fail to reject the null hypothesis? You need to state the p-value, and you need to say, hey, is there evidence for, or maybe not enough of evidence for the alternative hypothesis? These are the 3 key things that you need to include it in your conclusion. So let's look at the example that we have here. Okay, a current antacid provided a relief for 70% of people who use it. A pharmaceutical company has a new drug and they want to test whether it is effective. They run a study with 100 randomly selected patients, and the 75% experienced relief. Is this an evidence that the new drug is better? Okay, the first step, I usually want to identify or extract the, let's say step 0, extract the important information, the useful information. Okay, 70% of people who use it, that is something that we want to prove. So we have a p0 equals to 0.7, and then it states that, hey, they run the study, which is our sample distribution. 100 randomly selected patients, and 75% of them experience relief. So that means our p hat is equal to 75 over 100, which is 0.75. What's the sample size? The sample size is 100, because they select 100 patients or people. And then they didn't say, when you do a hypothesis test, you need to look for the significant levels, which is our alpha. So alpha, if it didn't state, we will default alpha would be 0.5, 5% or 0.05. Okay, so now write down the hypothesis. Hypothesis is what? Something that we want to prove. No, something that we assume that our assumption that, hey, these provides relief. 70% of people believe that this provide relief. So our p0 equals to 0.7, and the alternative is what? Hey, it said the new drug is better. Better means it's more than, right? So we have alternative is better than 0.7. Okay, let's check the condition to use a normal distribution. So what would be the condition? Central limit theorem. So independence, check. Randomization, check. Okay, success and failure test. Again, this is built around the null hypothesis. So we have m times p sub 0 equals to 100 times 0.7 equals to 70, which is greater than equals to 10. M sub q equals to 100 times 0.3 equals to 13, which is greater than 10. So they meet that criteria. So that means we can apply our normal distribution or use our central distribution. Okay, so our mu is equals to p0, which is 0.7. Sigma equals to p0 q0 over n, which is 0.7 times 0.3 divided by 100 equals to 0.0458. Okay, so now let's draw the normal distribution. So we have a p hat, which is 0.7. One standard deviation is what? We add 0.7 to 0.0458. And then here is add 2 sigma. So just do it by yourself. So we know that our p hat is equal to what? Our p hat is equal to 0.758, which is a little bit in here. So this is going to be our p hat. So our p value should be the area of this part, right? So we'll talk about that later. Now let's get back to the test statistic. So test statistic is z equals to p hat subtract p naught divided by the sigma. So why this is p naught? Because we want to subtract in our mu, which is our p naught. So we have p hat is equal to 0.75 minus 0.7 divided by 0.0458. We calculated from the previous step. Okay, so we end up having z equals to 1.0917. Remember, z score is built around a standardized normal distribution with the center 0, 1, 2, 3. So 1.97 is approximately our z-scores here, 1.0917. So our p-value would be this area. So there's a two-way that you can find p-value. You can either put in the sample distribution into GeoGebra or the test statistic into GeoGebra. You should end up with the same results. You can either use this one, or you can just put in one and use the other one to test, see if you got the same result. So we have our p-value. From GeoGebra, we got our p-value equals to 0.1376. Now is the conclusion. First of all, we need to compare our p-value to our alpha. See if it's smaller than the alpha, the significant level, or greater than alpha. So I would like to convert this to a percentage. So we got that. So we have what? Our p-value is 13.76%, which is greater than our alpha, which is equals to 5%. And then since it's greater than, we fail to reject our null hypothesis, and there's not enough evidence for the alternative hypothesis. So now this is how we're going to write it. We fail to reject the null hypothesis with a p-value of 13.76%, and there is not enough evidence for our alternative hypothesis, which means something that we're trying to prove. That's our null hypothesis, alternative hypothesis. The new drug is better. Okay, so that's the whole thing for the hypothesis test. Now let's use another example and try this. Step 0, extract the important information. Okay, a company develops that it hopes will be better instruction for its customer to set up their own smartphone. The goal is to have 96 of customers succeed. So that's their goal, that's what they want. That's the assumption, right? So we have p naught equals to 0.96, and then the company tests a new system on 400 people. Okay, so that means we have a sample size of 400, of whom 376 were successful. That means p hat equals to 376 divided by 400, which is 0.94. And is this a strong evidence that the new system failed to meet the company's goal? Failed to meet, that means it's less than. So set up our null hypothesis, which is p naught equals to 0.96, and the alternative is they failed to meet, which is, we want to say this is less than 0.96. Okay, central limit theorem. So independence, check. Randomization, check. Success and failure, test. Okay, so let's take a look. N times P naught equals to 400 people times P naught, which is 96, is greater than 10, definitely greater than 10. And then N times Q naught, the failure test, which is 400 times 0.004 equals to 16, greater than 10. So that means they check the success and failure test. Now we set up the sampling distribution of proportion and the test statistic. So we have mu equals to P naught, which is 0.96. Sigma equals to P naught times Q naught divided by N and take square root. So we have 0.96 times 0.04 divided by 400, because they tested 400 people. So we have a sigma equals to 0.009798. Okay, and then we draw the normal distribution on it. The center is 0.96. One standard deviation would be 0.969798. And then you add another standard deviation. Okay, so our p hat is what? P hat is 0.94, which is approximately here. This is our p hat. And then we have our p value on the left side. This is left tail, since it's less than, it's left tail. So we will use a GeoGebra to find that. Okay, now test statistic. So for test statistic, we have a z-score equals to p hat subtract mu divided by sigma. P hat is equals to 0.94 subtract 0.96 divided by 0.009798, which is equal to 3.918. Again, use the calculator to calculate it by yourself. So here we have our z score normal distribution. 1, 2, oh, this is negative. -1, -2, -3. So our z-score is approximately in here. This is of z, which is equal to -3.0186. So here is going to be our p-value. And then we use GeoGebra to find the p-value. So now let's take a look at the GeoGebra. Okay, so I'm going to use a z-score. So since the left tail, we switch to left, and then this is less than 3.0618. So we got our p-value equals to 0.0011. Okay, and then we convert this to a percentage, so we don't mess up. So our alpha, by default, alpha is equals to 5%, right? So 0.11% definitely is less than our alpha. So that means p-value is small. We need to reject our null hypothesis. So we reject our null hypothesis with a p-value of 0.00%. And then we need to say there is evidence for our alternative hypothesis, which is something that we're trying to prove. The new system failed to meet the complaint's goal. Okay, so that's it. That's the whole proof for the hypothesis test. So let me know if you have any other questions.